fifth grade. Really ain't no difference if that nigga gay.
Blood satellite.
I don't know how Brian Stelter ended up where he is. The worst face in America. An untrustworthy looking and sounding man. Because at the very least, you look at Keith Olbermann. At least Keith Olbermann, he's insane, but he sounds like a trustworthy guy. If he looks, yes, here's the news of the day. Brian Stelter looks like a guy who runs a fucking food truck.
Yeah, Brian Stelter is the Tom Hanks of the news world. He has no business being there.
Tom Hanks ruins things he's in. I forgot to mention that earlier. He's in a new Elvis movie by Baz Luhrmann, who makes these big bombastic movies about musicians and stuff. And I watched the trailer. I think it's just called Elvis. And the guy that got to play Elvis, I think, looks and acts fairly well. Tom Hanks immediately takes me out of it. He's doing his weird accent. He does this accent. Like when he tries to sound American. I don't know how else to describe it. Tom Hanks brings up this fake American accent. He's acting old. It's just that. Watch the trailer for Elvis and tell me that Tom Hanks doesn't rip you out of it. And I'm telling you, ripping you out of a Baz Luhrmann movie where everything's already cranked up to 11.
Yeah.
They're really relishing the mythology of Elvis where women were coming in their skirts, seeing him move his hips. When you actually look at like footage of Elvis performing, everyone was just kind of sitting there and clapping politely. But they, like the Beatles, it's like, do you know how many women were spraying piss on each other in the crowds? I'm like, no.
None.
Why? First of all, that didn't happen. Second of all, why do you want to believe that? I don't like that you believe that and want me to believe that, Mr. Stelter. This is a Mr. Stelter story. Did you know that women were projectile pissing in the back of each other's fucking skulls the moment they saw this guy go, well, they'd never seen that before. Well, Mr. Stelter, that is not accurate. I don't know what we were talking about.
It was not related at all, but somehow it's Brian Stelter's fault that this fucking movie is ridiculous.
Yeah.
But I'll take it.
I think we're talking about shipping containers. Was that?
Yeah, we're talking about shipping containers. We're talking about the everything crisis, the everything shortage.
Because to me, it's like people more intelligent than me will try and unpack this, and they'll debate about here's a hidden reason it's happening that they're not talking about. That this is a kind of a cyclical market-based thing. That it's actually the government put these restrictions in that you didn't know about. That a lot of that's true. Like, Trump did this, then Biden, he took off these sanctions, then put these sanctions back in. So that's the result of this price hike, and maybe it's a few price hikes tied to a few government things. But to me, I look at all that, I'm like, that's all accurate. But to me, we're just putting a magnifying glass up to a broken machine, a machine that broke in 25 different places. And you can say what each one is, and that'll be true. But collectively, the idea to me is that if you fix one, it won't fix everything. So that's the problem, that it was many concurrent failures, so that if they rejiggered some kind of sanction or a trade thing, well, that's actually not going to make the baby formula problem bad. That's not going to get, the fact that no one is applying to these shitty jobs will not be impacted by any of that. That's a separate issue. And they call that.
Somebody in one of those articles talking about it being a cascade. Cascade is the perfect example. It's a snowball rolling down a hill. Once it starts moving, you can get out of the way if you're lucky, but you can't stop it. You're not going to stop it. It's just going to keep getting bigger until the final penultimate disaster happens. And that might be a ways down the road, but I mean, you can't stop this now. It's already in motion.
Yeah, it's I always bring this guy up, Mencius Moldbug, but let me just say for the record that there's a lot of what Curtis Yarvin has said that I don't agree with. I find what he is good at is I'll put it this way. There's two things that a lot of these kind of e-celebs and these ideologues are good at. I find there's the data and then the ideology, two hemispheres. So I find some people are very good at the data, getting the facts, gathering the stories about, let's say it's crime statistics. Let's say it's about how things have changed over time in history. So that's data. That's immovable. But then you can't just have data as an ideology. You need to use that as an animating force for some larger system that you think can course correct society or build a better civilization. Where a lot of people go wrong, I think, is they sit in the data. And this is where you end up just complaining about things like about crime statistics and IQ and stuff. And those are all true. Those are all relevant, but that's not a coherent ideology on how to fix anything, right? So, but I find Curtis Yarvin, like people like complain about like racialist stuff. It's true, but that can't be your whole thing. You have to use that as fuel for something else to fix it. Otherwise, you end up just like a lot of people do, just complaining about minorities your entire life without doing something about it, or creating a new system, or figuring out how to go forward and create a better world based on that. So I find he was very good at that, about like, here's how things are. Now, his prescription for that is like making a blockchain king of the world. It gets really kooky. I want to dive more into it, but he's got a strange model for how to make a multipolar world. Anyway, but he was talking about monarchies, and he was talking about, he likened it to holding a telephone pole up. Like if you're a telephone pole that's just kind of free floating on the ground, he's like, if the telephone pole is standing up, you can actually hold it there with one hand. One person can hold it there with one hand. But the more it starts to tip over and the more force it has, the less one guy's able to stop it. And then once it falls over, to lift that pole back up to its kind of balanced position takes a lot more than one guy. Yeah, you need a crane. You need like a bunch of people and a crane. So that's kind of what he was looking at when he's like, when things fall apart like that, once it's barreling down the hill, you can't possibly have a small thing. You have to, I guess, wait for it to collapse and then plan to rebuild it again, because you might not be fast enough to stop that telephone pole from falling. But, at that point of perfection, you actually don't need much machinery to keep it perfectly balanced like that.
Yeah, and I think I like that analogy, because there's two things going on there. One of them is like the velocity of the crisis, and the other one is the size of the crisis. So you can have a huge crisis, like for example, the climate crisis, to the extent that it's real, is a huge crisis with a low velocity. We do have decades to resolve it, right? Or we have had decades to resolve it. But with this crisis, this is a fast-moving crisis. So even if you had the ability to muster enough resources to solve this huge problem, you wouldn't be able to do it anyways, because the amount of time involved in planning a project, like it's like an asteroid hitting the Earth. Like you're not, and by asteroid hitting the Earth, I mean it's a 3-year crisis, not a 50-year crisis. You're not going to be able to solve this economic problem in the next 2 to 3 years, which is what you need to do. This needs to be resolved. This needs to be resolved by like 2026 or 2027. If it's not, half of us aren't going to have power. I think by then.
So, and that's why when I conceptualize these different issues, when I say the system is failing, you say, well, what is the system? The system is kind of a bunch of overlapping things, and each are failing uniquely. So if you say, and by the time it reaches us on an individual level, you're actually seeing like 6 or 7 collapses.
Yeah.
So you could say, like, is this a failure of liberalism? Yeah, actually, I think a lot of things are the failure of liberalism in centering the fringe and centering minorities and completely. I talked about this with Dr. Ricardo Duchesne, which is an interview which will be going up at some point in the future. I have to kind of space them out. But talking about how this is kind of an inevitability of liberalism. It was always going to happen. It's not like it was hijacked by the left. This is in the DNA of liberalism. But the pivoting from minority rights, from being the minority rights of whoever's in your nation, which is kind of how Russia conceptualizes it, into a universalizing minority rights for all minorities, and not being able to delineate between minorities in Ghana versus Canada, whereas a minority in Canada would just be Quebec. So you want minority rights for Quebec, but the idea of bringing in migrants as minorities is a new perversion of that. So you could say, yeah, but that's inevitable. Why? That was a test that liberalism failed. And so, yes, that's one failure. Then there's also the failure of free trade, of the way we set up these supply chains. That's another one. Then another one would be, central banking, the Federal Reserve, and how that kind of gloms onto everything else, and that failed in different ways. And then there's a bureaucratic issue. Then there's the loss of religion. You can say all these things, and some of them are connected, some overlap, but then fixing one wouldn't fix everything. And so that's why I try and have a different view of how they interlock, because if you do that, then you might be able to see a future out of this. And like we were saying before, that I think the winning ideology in the West will be the ideology that has something to say about all of this. And I don't think you can have a successful political ideology that ignores COVID and the results of COVID. I don't think you can have one that ignores sort of a technocratic elite making moves on the global stage and the impact of technology on how that will force our brains and minds and maybe even our physiology to develop over time. I think you need to have an opinion on that. That will be anti-conservative because conservatives can't have an opinion on anything in the future. And I think to inspire people and gather people around us, if you want to make our ideas more palatable, you have to find a place for them in the future for people and not always look to the past. Anyway, point being, when we gather people around us, we have to have an opinion on all these little things about how actually society is set up. And it'll be different things, because if we get rid of all of the illegal immigrants and the migrant crisis tomorrow, we still have a lot of issues to grapple with to establish national sovereignty. And not only that, but like reestablish who we are as a people. Like, in one sense, you are under threat by, if you're in Canada, Chinese investment. That's one. The refugee crisis. That's another. That's a very lived reality that people have to deal with. But that's also like Canada does conceptualize itself as a post-national state. What is the Canadian identity? We don't really know. So we could say one leads to the other. One problem follows the preceding one. That true, but that is also something we need to deal with. Like, who the fuck are we? What is Canada? We don't really know. And if we were free of all the refugees and all, if we could turn back the clock and all these Sikhs running the show over here, we would still have to answer for that. And that's where it gets kind of complicated. Anyway, I'm just rambling now, but that's how. When we look at the everything shortage, we also say, well, the everything shortage is a failure of everything. And it's not like one thing went wrong. Anyway, that's what I was saying. And you could say that's maybe a scientific way of looking at it. And I'm not trying to toot my own horn because I don't use scientific as superior to anything else. But the task of breaking things down into their smallest components, I think, is essential, because this will sound like a strange criticism, I'm sure. Like, I'm still working through this in my head because I read a book recently and I really like this book. I'm fascinated by this stuff, but I was struggling for how I could massage this and wrestle it into something for the show at some point to connect it to something else. And I want to talk about it because it's somewhat related to this. I was going to do it later, but maybe I'll do it now. The book is titled "Reality is Not What It Seems" by Carlo Rovelli. The subtitle is "The Journey to Quantum Gravity." So this is a theoretical physics book. This is a quantum mechanics book. So it's not political. And even though it's probably written by a fairly liberal-minded guy, probably a progressive guy, it doesn't really come through except at the beginning a little bit. They'll talk about how good secularism is and how good all the canards they roll out. But it'll sound like I'm muscling the point that I might be trying to connect things too much. And this is something I want to avoid because I remember many, many years ago, there was this guy named Deepak Chopra who's still around. He's an Indian guy, sort of a new age thinker, an Eastern philosopher. And he got into quantum mechanics, and he was known as a guy who would use the language of physics and quantum mechanics and theoretical physics in this sort of mishmash of philosophical ideas. And I remember seeing him in a debate with Sam Harris at one point. I don't know how long ago this would have been, but it would have been when people gave a shit about atheism debates. So I might be dating myself there. But that was one charge that was made against Deepak Chopra, which is saying, like, you're using words like a superpositionality of possibilities in relation to the soul. So it's like, it's a lot of words. Like, I can tell you're trying to use these words in a way they weren't designed to be used to elevate the bullshit you're talking about.
Today, science tells us that the essential nature of reality is non-local correlation. Everything is connected to everything else. that there's hidden creativity. There are quantum leaps of creativity. That there's something called the observer effect, where intention orchestrates space-time events, which we then measure as movement and motion and energy and matter. And addressing Sam, we can have a personal relationship with this intelligence, because we have a consciousness that is part of the sea of consciousness. Rumi, the great Sufi poet, said, you're not just a drop in the ocean, you're the mighty ocean in the drop. And all you have to do is understand the principles of science and understand that you have within you the...
And I don't like that. So that's not what I'm trying to do. I'm not trying to just glom on these concepts into something else, something political. But when you read stuff like this, like, it does inspire new ways of thinking. It does shift your paradigm a bit. And I just find it very interesting. I know you do too. You're an engineering minded guy. You're a science minded guy, even though we dabble in the conspiracy theories, even though we get into all the esoteric stuff. I just love this stuff. I love talking about wave theory, you know, even though I'm not a mathematician. I'm a huge idiot. I'm the dumbest man in Canada, but I still have a podcast and you're listening. So what does that say about you? Here's the thing. This stuff is explained in a non-mathematical way. And I got a bit too big for my britches recently. I'll tell you about this. I'm like, oh, I love this stuff. I'm going to read this book called The Road to Reality by Roger Penrose. If you know anything about Roger Penrose, he's a brilliant man. This was so far out of my league, I felt depressed. Because this was also like a book for the people. It's not really heavy math, but I'm like, okay, The Road to Reality. It's about explaining. This is a 1,000-page book. This is explaining everything there is to know about the universe as we know it right now, going back to the earliest, most fundamental, basic stuff, and then getting into the weird stuff later on. And I sat down, and right away it's math. I'm like, oh no. And he said, okay, first of all, let's spend 40 pages telling you about the mysteries of the triangle. I said, oh no. I went through this in high school. I knew I was dumb then. Now I'm actually smarter now, so I'm more aware of how dumb I am on this, which is worse.
Having a Bart Simpson moment. Yeah.
Yeah. I'm like, oh no. And then I'm skimming pages because I'm like, and then it obviously builds on the previous thing. So I'm skipping 50 pages. I'm like, it's like, okay, now let's get into circles. Are you ready to get your fucking ass raped? Quote, Roger Penrose 2022. Are you ready to get your fucking butthole blown the fuck out by cylinders? Like, oh no. And so I had to go back. I got to go to the books where it's explained for people like me, where it says, I'm sure you heard about Isaac Newton. And here's a little anecdote about him, how he did something cool. Now, you've probably seen a frog. Frogs are a lot like the universe. And I go, ha ha ha, yay! That's a level I got to go at. But this book was great for me. But reality is not what it seems. He basically explains about the relationship between all these different types of physics and how they evolved as separate ideas over time, separate domains, and then up until our current understanding of the universe, how everything is kind of conjoined and smoothed over. Everything is just this one sort of wave.
In quantum mechanics.
Well, we had this idea from Rutherford that atoms look like little solar systems. But people very quickly realized that can't possibly be right. Because if an electron is orbiting in a circle, it will give off light. All the light that we have in this room comes from electrons zooming up and down and wiggling, and that's what electromagnetic waves are. And you can calculate how long would it take for the electron just to spiral into the nucleus. And the answer is 10 to the minus 11 seconds, okay? 100 billionth of a second. So that's not right. Meanwhile, people had realized that light, which we understood from the 1800s was a wave, had properties that were similar to that of particles, right? This is Einstein and Planck and stuff like that. So if something that we agree was a wave had particle-like properties, then maybe something we think is a particle, the electron, has wave-like properties, right? And so a bunch of people eventually came to the conclusion, don't think about the electron as a little point particle orbiting in, like a solar system. Think of it as a wave that is spread out. They cleverly gave this the name the wave function. Wave that is spread out for one of the most profound things in the universe. There's literally, a number at every point in space, which is the value of the electron's wave function at that point.
And there's only one wave function.
They eventually figured that out. That took longer, but when you have two electrons, you do not have a wave function for electron 1 and a wave function for electron 2. You have one combined wave function for both of them. And indeed, as you say, there's only one wave function for the entire universe at once.
And I just thought I'd go through the things I learned from this book that were explained in a way that it tied everything together. And I think it's cool. And I thought you might want to know it. And I do think it somewhat relates to the lives we're living right now, what we can do to make it more practical. But because the reason is that I find that on the right especially, we tend to think in terms of infinity and eternity a lot. So we kind of have this sort of abstract notion of man, of the soul, of spirituality, of human nature, that things are just limitless or endlessness. What I found is once you bring everything in the world of physics, traditionally, that's how physicists thought of the universe, that, the universe was, we knew that there were forces at work. We knew that there's things that are happening, but we don't really know what space is. Space, we had this idea of this thing called the ether, and the ether was this sort of, it's like a mist that permeates the world, that this is how electricity can transmit. Things are being transmitted through the ether. It's not air, it's not gravity, but it's kind of the canvas upon which all this is. So they had this idea that there's got to be something that allows these interactions that we're noticing. And then we kind of segmented and siloed these ideas. Like we have gravity over here, and we have space over here, and time is over here. And we kind of know these things exist, but we don't really know how they relate. But they're infinite. Like space is infinite. Like heaven and hell, it's infinite. And that was almost used as shorthand as we don't know. And then what I liked about quantum mechanics is people still, when it comes to quantum mechanics, think that means like, oh my God, you can go down infinitely small. No, the point is you can only go down so small. Within quantum mechanics, it's this idea of sort of like the Planck length, or once you get down to like the smallest, quanta means quanta. Quanta is the Latin word for like one indivisible unit. So it's like, how small can we get into the matter of the universe? And we actually know the distance, that there's nothing smaller than this.
Now, Planck was the first person to come up with this length because he just invented quantum physics by studying black body radiation.
Now, the history of it's quite strange because back in the 1880s, Max Planck and others were thinking about the heat and light energy that was coming out of hot bodies. And in the course of that, he started getting a feeling that there was something quantum mechanical happening. From that, he came up with an idea of fundamental units for mass, length, and time. And the unit of length is called the Planck length.
And we actually know that the universe is not endless. We do know that there is kind of a boundary to the universe. And we do know that there's limitations on the universe around us. And I found that interesting because it challenged this sort of conceptualization we all have of the universe, where deep down we kind of think everything will last forever. And we think that everything can be like eternal and infinite. It's not really. And once you actually put bookends on existence, it changes how you conceptualize things. Because once things only can get so small, we can draw a boundary around it. Say that's the limit of our understanding, and nothing exists outside of that understanding. Yeah. And I always I related that to even political theory when I was thinking about it, that this is something we talk about all the time on the right, about like what is the quanta of society. So quanta meaning like the prime unit. So for the liberal, the prime unit would be the individual, right? There's nothing more. It's indivisible. You have the sentient, the sovereign individual. Whereas people on more traditionalists would say the quanta of society is the family. That's more about what I believe. I would believe that the perfect unit of a society would be the marriage of a man and woman with kids. I think that's where that brings the woman up to her best level, that brings the man up to his best level, and the children mean the stakes in society. And that unit, within that unit, you can have an organization that to make your land, your house, to have it working in order. And if you have just too many people going around single forever, they kind of go insane. I was joking with the Prudentialist about that in our interview. People listening to that, go to our Odyssey and check the Prudentialist interview. Because this is something I see a lot of guys feeling, whereas if you don't have kids, if you're a woman and you don't have kids, people talk about that. Talk about hitting the wall. They talk about women kind of lose their minds in their 40s. They don't have kids. They start, going in weird directions. Happens to guys too. If you're a guy and you're in your mid 30s and you don't have a family, your mind starts doing weird stuff to you. You're like, what? It's like your mind is saying, "Oh, this one's not going to reproduce. Let's kill it and start over." Like there's some kind of fucking lizard brain thing where childless guys in their 40s, there's like a sad desperation. You're not doing the thing you should, and your body knows it. But that's why I think the unit of a functioning civilization is the family, and then anything below that is just matter. I don't know, but that's the debate we have. That's the left, and then some people would say that even the individual and the family is too small. It's like the collective. Like there can't be anything lower than this kind of general collective. You get into anarchist theory and things like that. So that's what the debate is. But I liked the idea of defining what the quanta of society is, because I think if you start with that, you have the floor that you build everything else out from.
Right.
And if you don't establish that floor, you're going to be talking about ideas you don't have any grounding in. So that's why I kind of liked how quantum mechanics, rather than exploding everything, which is what people think of when they think of quantum mechanics, like this is the thing that just challenges our conceptualization of the universe and it breaks everything. But that's not, in fact, true. Now I'll give you a kind of an overview for people who don't really know much about this. Like I had ideas and I had kind of a vague understanding of all this stuff, but I'll just lay it out for people how the universe as we know it now works. Now, as we get to the end, as we catch up with where we are right now, that's where there's still some debate about like what quantum gravity is, but it's actually very fascinating stuff. So I'll just go into it now. So atomic theory is the theory that matter is composed of finite points. Now, this is a very old theory, but there was a time when this was new, that you break things down and the matter is very, very small, but not infinite, but very, very small. And then and that's what gave way to the theory of infinitely subdividable distances, because that's what people think. People knew that, you can probably get smaller, maybe get smaller forever. But atomic theory said, no, here's what the components actually look like. And then once you start magnifying reality, you start getting, okay, what is space? And this is where Einstein comes in. Now, I'll say Einstein, even though once you look at the history of scientific revolutions, and we might get in this next episode, but you realize that it's usually never one guy who's truly responsible to it, but it's usually no more than 3 or 4. So when they say Einstein discovered general relativity, it is true to say that there was a couple other guys who were working on it, and arguably a couple other guys who came across it before him, but he was the first guy that published it in this form, and maybe he even stole it from these people. But that's a debate we won't get into. That there's a lot of people who say Einstein was a fucking fraud. I can believe it. I can believe that he just stole shit from other people, but they love the story of Einstein. That, did you know Einstein wasn't even good at math in school? And they'll say that as if to say, look, you can be the next Einstein. I'd say, okay, so maybe Einstein was a fucking fraud.
Yeah, exactly.
maybe we're getting into another Helen Keller situation here. Maybe you're just wrong. I'm just saying maybe. I'm just, I'm splitting the difference.
Maybe, definitely. I mean, you can't trust him. You can't trust those people.
So general relativity is pretty interesting. A lot of people don't really know what it is, but Einstein discovered that there's no such thing as empty space, really, which is what everyone thought before. We have particles and what are called fields. Existence bends and moves from different forces, and it's not just empty space that has a bunch of stuff filling it. So he was not the first, but one of the leaders of this movement that everything is kind of impacting each other. It's not just I have light over here and gravity, and then they exist independently of each other.
You see, Einstein taught us in general relativity that space and time are not an inert backdrop. They participate in the unfolding of the cosmos. Space and time can warp and curve, and that creates the force of gravity. When you recognize that space and time are dynamic, they can change, that they're real physical entities, well, then they must be subject to the laws of quantum physics. And the key element of quantum physics that's relevant is the uncertainty principle. When applied to space and time, it says space and time are uncertain, which means they can wildly fluctuate. They can, in a sense, look like the violently boiling surface of a pot of water when you examine space and time on fantastically small scales.
And this is why general relativity combines space and time and magnetism with electricity. And then that's where you get this idea of mass and energy. Because before, I'm like, I know what electricity is, I know what mass is, but we didn't know how these things were related. So one of the things they discovered general relativity, because we would always think time is consistent and eternal, just like everything was consistent and eternal and just kind of moves. He said time is malleable. Time can be impacted. So it's to the point where, and this is something we can prove on a very, very small scale, that gravity impacts time. If you've seen the movie Interstellar, you'll know this, but that was kind of a pop version of, like, if you are closer to something with strong gravity, time moves differently than something that is moving away from it. So people in space age slower than people on Earth. That's just a fact.
And while this may seem abstract, I can guarantee that every single one of us here today does care and does use this level of accuracy in our understanding of gravity. While we spend 1 hour on the surface of the Earth, GPS satellites on orbit 12,000 miles above our head fill 1 hour and a tiny, tiny, tiny bit more. 1.5 microseconds more to be exact. That's 0.0000015 seconds more. This is ridiculously small. And yet, this very subtle difference due to effects of gravity, if not accounted for, would accumulate, and GPS devices would give you positions which would be miles away from the correct ones.
Furthermore, we can even measure this, that people who live on top of mountains, believe it or not, live a bit longer than people closer to the ground. Now, it's not going to be by years and years, but you can tell from the cell degradation and stuff, like things age differently based on gravity. So, like, okay, gravity impacts time. Gravity also impacts light, because before we thought light wasn't impacted by gravity. Of course it is. So now we start seeing how all these things impact each other. And the more we drill down into that relationship, the more relevant these interactions are. And that's how, like, magnetism is combined with electricity, and all these forces are in this sort of, thermodynamic idea. And this is where field theory came in. And field theory was about electromagnetism. This is where you get the entire concept of electromagnetism, whereas before it was just electricity and magnetism. So they believe that there's kind of this field permeating everything in the universe and governing the relationships between them. And so you have gravity, and then electromagnetism is like another form of gravity, right? And this is how they conceptualize it. They conceptualize it as actual, like, they said, okay, think of lines. There's all these lines in the universe, like a sheet of paper, and you can't see them because they're so small, but everything travels along these lines. And that's how these forms of energy and light and electromagnetism are affected. So these lines are what electromagnetism is. And this is where kind of flat earth theorists get into this, and conspiracy theorists on that level, where they say gravity doesn't exist, but electromagnetism exists. Now, once you learn about both of those, you're thinking, well, you actually can't have electromagnetism without gravity. See what I'm saying? Because they'll say gravity doesn't exist, but, so nothing orbits itself, but we have electromagnetism to explain why when I drop something, it falls to the ground. But you actually can't separate electromagnetism from gravity and also time, if you're doing it right. So that's where they get confused. They just haven't read that part. And that's where, once you start getting down at that level and imagining how these forces transfer, that's where you get the idea of particles. And particles are just a quanta of a field, like photons are a quanta of light. That's, people know what lights are. Light's made of photons. And so particles operate like photons are. It's just these things that are everywhere and they're moving. And they say there's 15 different fields in the standard model constituting everything we see. So that's what field theory is, that there's just these interlocking and layered fields where different forces interact and play around with each other. And there's 15 of them in the standard model that we know from now.
This is the standard model. It describes how everything in the universe is made of 12 different types of matter particles, interacting with 3 forces, all bound together by a rather special particle called the Higgs boson. The Standard Model is written in a language known as quantum field theory. This tells us that matter, at the fundamental level, is not really made up of particles. Instead, it's made up of fields, fluid-like objects which are spread throughout all of space. These fields are engaged in an intricate, harmonious dance to a music that we call the laws of physics.
And so everything in the universe is just manifestations of fields. That light is the interplay between electromagnetism and gravity and all these other things. And that's how we look and we see the world around us. And they said, the quote in the book is, the universe is just a covariant quantum field, that's fields that live on top of themselves. So we can say not only what governs each particular field, but we can see how they interact each other. And then once we see that, we actually have a very good explanation for how everything is. But that's what's so interesting, that we say it is divisible, but it is all connected. That's what I found so interesting, that traditionally, again, like light, gravity, all this stuff were different silos. We didn't know how they interact. But we can say everything is kind of connected while also saying they're separate and unique. So with connecting them, you don't just get this mishmash of stuff. You actually, it is divisible. Like quantum theory is divisible, but everything is relational. And that's how they say, the line in this book that I really took to heart was that the universe is just, and this sounds obvious to some people, but it is just the manifestation of relations. And there aren't just eternal forces that are present, that you can differentiate with them, but they do have their boundaries, and they actually don't exist. They don't exist in their form unless they interact with other forces. Now, why is that relevant? Now, again, this might sound like I'm connecting a few dots, but I looked at that almost from a political point of view, where I said, the one thing we're obsessed with on the right is making these evergreen, standard, permanent, huge ideologies that are designed to exist outside of everything else. And when I read stuff like this, or when we do even a reading of history, we say how much of these successful ideologies were based after other movements around them. Like if you look at the Third Reich, look at the Communist Revolution, look at the Anarchist Revolutions, like these sprang out of relationships with other ideologies. It's like they weren't trying to make this perfect mountain of an ideology. It has to exist as a reaction or as in a relationship with other ideologies. And if you look at the rise of, for example, Hitler, he had to deal with the conservatives. He had to deal, a lot of the fascists had to deal with the religious element. They couldn't just say, we're replacing everything. You had to evolve over time. It was way more fluid. And so I think we do ourselves a disservice if we're trying to craft new systems for which to orient ourselves and organize society, if we say it can just exist apart from everything that exists now. And this is what I said, that the successful ideology, whatever it is we settle on to save our fucking civilization, hopefully, is going to have to take into account these other forces that are at work. And you don't have the luxury of ignoring it. You don't have the luxury of ignoring technology if you're trying to design an ideology, or saying that we'll sort that out later. You don't get to do that. You don't get to live in a fantasy world where we just get to ignore these things. You don't get to ignore like the current state of global trade. What are we going to do about that? What are we going to do about space? If you don't have an opinion on space, you're not cut out to propose an ideology. That's going to be very real, very fast, and you're not going to be able to control it. So that's why I say if we're designing systems, these systems must be designed in a, let's call it a scientific way, where take into account the relationship you are going to have with these other forces in the world just to survive. Anyway, that might sound like I'm reaching too much, but that is something that I read this book and it seems so obvious, because that's just how the universe and the world works. And then we can go into more stuff, how the universe works. Like when we talk about like energy, again, we're talking about quanta, we're talking about finite packets. That's what the Planck constant is. The Planck constant is the amount of packets of energy in an electromagnetic wave. And that's how you get into stuff like light. Like, what is light? What controls the color of light? Well, Here's where it gets kind of interesting. This is where you get more into quantum theory. Talk about electrons. Light changes color once you look at it because electrons change color. Why do electrons change color? Because they move. Electrons in orbit actually move between orbits. And we can look at this. We can actually test this, but here's where it gets complicated. So electrons change, they cause color change, or they cause color period based on their movement and frequency in relationship to the nucleus. Now, as they move between orbits, they cease having a position. And the way they explain this, it's like if you're looking at a street at night and there's street lamps, that's the only light you can see. And you see a man walking between street lamps. You see him under one street lamp and he's in darkness. He's not there. Then you see him at another street lamp. So you know he exists. You know he moved. But the entire process of how it moves, you don't see it move. That's what they call a quantum leap. That's where a quantum leap comes from. It's here, it's there. What happened? And this is where they get into stuff like superpositions. And this is where it almost gets philosophical, where it's like, okay, you've got an electron here and then it moves over there. What happened? Well, the in-between was kind of everywhere at once.
How do we know that superposition is real and not just an illusion due to our ignorance? One experimental clue comes from the double slit experiment. This experiment shows that a particle is indeed spread out, like a wave that can be in many locations prior to measurement. But after measurement, the particle becomes distinct and localized. This phenomenon is weird enough just for a single particle, but with entangled particles, it's even weirder because it then seems that a measurement on one particle determines the outcome not just for that particle, but for both of them. When we only measured electron 1, the measurement not only forced the universe to choose between spin up and spin down for that particle, it forced the opposite choice for electron 2 because of their correlation.
It's like a Schrodinger's box thing. It both exists and does not exist, and you don't know until you see. And this is where they get into the uncertainty principle. Like by the very fact of looking at things, changes its position. But it's that times 10, which is that at this level, you're everywhere and nowhere at once until you're not. And so they call that a cloud of possibilities. And we only know things exist when they actually interact with each other. We only know things are there when they're done moving. And once you hear that, like, okay, wait, that doesn't even make sense. Wow, that's crazy. But that is the best conceptualization we have right now about things. So there's a huge black box in the universe where we actually don't know what happens, and it could be that everything happens all at once, and then it decides on one possibility based on its relationship to everything else in the universe. And that sounds like it's an unfulfilling explanation, but that's all they got, which leaves the door open to maybe more spiritual or kooky or new age explanations, because there are huge gaps in this theory where you could just put in some grand designer or some, because they'll say, well, once we get down to the quantum level, there's forces at work that make decisions on where things are. Well, how does it make a decision? We don't know. We actually don't know why these electrons decide on one. They call it more of like an averaging out of possibilities. Our entire universe is just a giant balance sheet of averages. But once you get down to that level, I can see where people would see that and say, oh, maybe there's gods down here. Maybe there's some form of intelligence. There's something that creates the balance. Because once we take it apart, we see more and more uncertainty and chaos. Now, I'm not saying that's what it is, but I could see how someone would come up with that explanation, because the best explanation they have right now isn't very good. There's a lot of question marks in there. And they call this, the name for this is actually Feynman's sum over paths. So they say from going from point A to point B, the electron is taking all possible paths at once and appears at one. Feynman's sum over paths. And that they'll say it in a way like that, but it doesn't really, maybe there is a mathematical way to explain it better, and I'm just, fat fingering this thing. I'm just fat fingering the bullet into my gun and shooting my dick off. That could be it. Or it's not. But that means that electrons don't actually exist when they're not interacting. Yeah. And that's sort of the law of the universe, that things only exist when they're interacting. So things can't just exist in a vacuum. Whereas I think that when we come up with ideas or political movements or reactions to things, we think things can exist in a vacuum, but you can only exist when you're kind of coming up against something, when you're manifesting. And how do you manifest something? Usually it's through conflict.
Yeah.
Now, again, maybe I'm reaching on that, but when we talk about thought in action, we talked this before, and we talked about Schopenhauer, about the power of will. Like, things only exist in the universe once they are willed into the corporeal world, into the existence. They don't exist in your head. Theories don't exist. Theories are plans. An ideology only exists when it's in the streets, once you figure out what it is clashing against. But until that, it literally doesn't exist. Just like tradition. Tradition doesn't exist. Rituals exist. Christianity doesn't exist if you don't have the church, if you're not preaching, if you're not, as Christ said to Peter, even if you're just standing on the rock and preaching, but it can't just be in your fucking head. And even Jesus Christ would probably agree with that in his own way, in the King's English as it was written. And just, I know some people might be going cross-eyed at this, but I'm trying to give a good overview without getting too deep into it. And I'm going to just read a part here. The matter surrounding us is made up of 1,000 different substances. During the 19th and 20th centuries, chemists understood that all these different substances are just combinations of a relatively small number of simple elements, hydrogen, helium, oxygen, and so on, to uranium. Dmitry Mendeleev put these elements in order in the famous periodic table, which is pinned on the walls of so many classrooms. Why these specific elements? What explains the periodic structure of the table? Why does each element have certain properties and not others? Why, for instance, do some elements combine easily while others do not? What is the secret of the curious structure of Mendeleev's table? Well, take the equation of quantum mechanics that determines the form of the orbitals of an electron. This equation has a certain number of solutions, and these solutions correspond exactly to hydrogen, helium, oxygen, and the other elements. Mendeleev's periodic table is structured exactly like that set of these solutions. The properties of the elements with everything else follows from the solution of the equation. Quantum mechanics deciphers perfectly the secret of the structure of the periodic table of elements. Pythagoras and Plato's ancient dream is realized to describe all of the world's substances with a single formula, the infinite complexity of chemistry captured by the solutions of a single equation. And that's just one of the applications of quantum mechanics. And then all this stuff gets really kooky once you get down to quantum gravity. And this is where you get into graviton. So people say, okay, we actually know what the substance of all these elements and phenomena are. We know that what the chemicals are made of, what light is, but what is gravity? And that's where you get into graviton. So gravity can be manifested on the quantum level, just like everything else, just like particles. But this is also where time breaks down. So you get this small, they'll say, oh my God, on the quantum level, time breaks down. What does that mean? But what that means is time doesn't really exist. Not the same way we think of it as sort of a linear arrow direction in time. He makes a claim in here. Once you start thinking about this, you get really kind of kooky. Like, time is just the measure of entropy. He says time doesn't create heat. Heat creates time. It's actually, time is just the manifestation of physical interactions. And that because time can be affected by so many other elements in the universe, even that can be slowed, it can be sped up, it can be stopped, that time as its own thing, as a thing we assume is just like a standard of the universe, doesn't really exist. It's just kind of a branch of like these other physical manifestations of things, which is a kind of a trippy way of thinking about it, but that's what they believe to be true.
You think about yourself right now. At the present moment, you are in some configuration, right? Your body is doing some particular thing. And a day ago or a second ago, it was also in some particular configuration. A second from now or a day from now, it will be in some particular configuration. But you don't know, right? You don't have exact knowledge. You have vague knowledge of what your body's doing right now. You don't even have perfect knowledge of that. You kind of have a memory of where it was, and you can predict where it will be. And let's think about that process, not at the scale of days or years, but of seconds or milliseconds, okay? The point is, we are constantly carrying with us in our minds an image of our body. And not just an image of our body right now. We have a pretty good idea of what our bodies are doing right now, even though it's imperfect, right? We don't have perfect knowledge of anything. We also carry around where our body was. We carry the memory of what we were doing just a tiny fraction of a second ago. And we project into the future. Our brains are constantly doing this. They're making predictions about where we will be, where our bodily configuration will be a fraction of a second in the future. And they're constantly comparing its prediction as we made it to what we're perceiving as where we are right now and to what we think we were doing in the past. It is that constant process of comparison, past, present, and future on millisecond timescales. That's what gives us the feeling that time is passing, the feeling that we are moving through time because there's an imbalance. We know a little bit more about the past. We make predictions about the future. We constantly take in more data, more information, and we update. And every single update gives us the impression that we are moving through time.
And that's why something existing in all states at once and then settling on one like a moment after, that's kind of how everything operates. We don't need to see it travel because traveling doesn't work. And time, if you think about time as we know it, it's kind of just measuring permutations of things. It's like our pulse. We'd say the pulse. We're not actually measuring time. We're measuring this thing that's beating and the distance between it. And then with our time, our version of time is just kind of calculating the orbit around the sun. So it's just a physical manifestation of this thing, but the essence of time as this sort of fluid thing doesn't really exist. Everything else is just measuring things like that. So,
yeah,
when we think, if you want to lose your mind, start thinking about how that affects our idea of the arrow of time. So when we think of tradition, we think about things in the past, or another way to think of it is it's not in the past. They're just dead things. They're just things we stopped doing. And the only reason anything exists in the present is just because we are doing it. So we keep thinking of the past as this place you can travel to or this place that we can reclaim. But really, it's just kind of stuff we stopped doing. That's why tradition and ritual is so important, because that's how traditions stay alive, by you doing it in the present. So if you're not doing it, it actually doesn't exist. And it can't even be relevant anymore. And you can't even really look back to it unless you actually figure out a way to manifest it in the present. So when we think about political solutions, it's good to take messages from the past and figure out what we need to go forward, but also consider that really all that matters is right now. All that matters is what you are able to do right now within the relationships you have around you with other movements, other power structures, that includes everything from the fucking cops right up until the communists you might hate, and the relationships you form, because the only way you can exist is in relation to these other things. If it just exists in your head, it doesn't exist. That's kind of what I was getting at. And that is, I tell you what, you can disagree with me. If you're disagreeing with me, you're disagreeing with science. Sorry.
Too bad.
Sorry. And he says one thing in the book that I really like, and this might sound kind of crazy, but he said, in relation to stuff like this, of superpositions and things existing, not existing, he said, having a precise precision and precise position is only for big things. That's a rule they go by, where like, once you get small enough, everything kind of exists at once. And that's why I was thinking about, if you want to be artistic and poetic, we could say that is the transition from the individual to the national, tracking the evolution of the rise of nationalism, the rise of people figuring out how to configure themselves to fight chaos, to fight the more we collectivize, the stronger we are, the more we make towns, we make villages. Whereas a guy in the woods is living in chaos, and you have chaos in your head. You don't know what's good or bad or left or right. You're a completely amoral being. The bigger you get with a family, with a tribe and a clan and then a nation, the more of a position you actually have, the more certainty you have. But on an individual level, once you get smaller, if the quanta of your society is just the individual, it can only be chaos. You can only just be an electron. And that's what you get with liberalism. You get a whole bunch of fucking electrons going off in every position possible, then kind of landing on one, and no one knows why. What we're trying to do is just give you a cupcake. It's big enough to be real. I groped my way through that one a little bit, but I think that's a good one.
Yeah,
You're going to remember that.
Yeah,
but that's
we
where.
got that.
Yeah, we got that. So when time doesn't exist and you get down to that level of gravity and stuff, then you get gravitons. Then you get into things called spin networks. So space itself is granular. You can look at space like you can look at photons. It's a thing you can measure. And so we know what is outer space. We know it's just not empty. We know it's not just ether. It's a thing we can measure. It's made up of parts, and we know how big those parts are. But they call them spin networks. And it's like these things don't inhabit a space. They are space, which, again, is kind of hard to conceptualize in your head. And they're only defined by relations to each other. Space is created by the interaction of the quanta of gravity. So space, as we know it, this thing we all exist in, is just like spin networks of gravitons. Now, I'm not going to get too much into that, but just to let you know, like, there is no kind of poetic abstraction. I think the poetic abstraction can kind of lead us into astray. Like, maybe space is the mind of God. It's like, no, if you want to have, you can have God and fit it into the data we have. Like we said, there's people who there's data, and then there's things you build from the data. And that's the ideology. That's the worldview. That's the system you create. So this is good data. I don't think this data should be ignored, but what we know about the universe. And you could fit in the other things you know into that, because there actually is quite a bit of space to fit spirituality, to fit a divine creator, whatever it might be, into this. So that's why I find it interesting. And you can still be a traditionalist in this space. Just to give a bit about what a spin network is, but before we end this, because we've got to end this soon. I'm sorry I'm taking up too much of your time. Did this make sense? Am I making sense in this at all? Or what do you think? Am I fucking this up?
You have not gone Deepak Chopra, if that's what you're worried about. You are not pulling a Deepak. No, I get what you're saying. You're essentially, you're using it as an analogy, as a way of describing 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 the nature of reality, but it's the nature of political reality, I guess, right? Like it's yeah, I get it. I do get what you're saying, and I like physics, so I'm good.
See, here's just a quote here. Space is a spin network whose nodes represent its elementary grains and whose links describe their proximity relations. Space-time is generated by processes in which these spin networks transform into one another, and these processes are described by sums over spin foams. We're talking about spin foams now. A spin foam represents a history of a spin network, hence a granular spacetime where the nodes of the graph combine and separate. The microscopic swarming of quanta, which generates space and time, underlies the calm appearance of the macroscopic reality surrounding us. Every cubic centimeter of space, every second that passes, is the result of this dancing foam of extremely small quanta. And he outlines it here in a graph. I'll put this at the beginning of the clip, but with Newton, we start in Newton. Imagine this as a table. Newton is responsible for space and time and particles. He knows these things exist, but he doesn't know how they relate. With Faraday Maxwell, they have space and time and fields and particles. So we know particles, but now we have fields around. We know how they interact. With Einstein in 1905, he combined space and time into space-time. So we have space-time, fields, and particles by 1905. By 1915, he combines space-time and fields into covariant fields. So you have covariant fields and particles in 1915. That's why we know the universe works. Now, with quantum mechanics, we have space-time and quantum fields. And then quantum gravity is combining space-time and quantum fields into covariant quantum fields. So at every step of the way, you see things as we understand their relationship to each other, the outline of reality actually simplifies without getting less detailed.
Yeah.
So I guess and the reason I say this, the reason I think this is all relevant is because I don't think when we look at stuff like this, how the universe is built and how these interactions happen, I don't see us as completely separate from that. Like how a lot of scholars understand just studying philosophy without also studying history doesn't make any sense. From an academic point of view, we have the sense that all of these siloed fields don't make sense. Like if you want an overview of how the human race, humanity works, like you need to combine history and philosophy and sociology and natural science, right? You have to combine it all to get a good sense of what it is. And over the time with academia, if you track the history of scientific revolutions, you see them overlap and start to combine into each other. Now we get a crazy extreme of that right now, but from us trying to craft ideologies and systems that work based on the data. We have more data at our hands than any other time in human history. I think there's so much we actually don't know what to do with it. But we need to create more intricate and more complex worldviews from a boots on the ground point of view, to carve out a space in this world for ourselves, because it's more complicated than ever to do that. And so whatever solution we come up with will have to be similarly complicated and nuanced just to survive. I guess that's kind of what I'm getting at. And also that everything is manifested through relationships and interactions. And anyway, I'm repeating myself now.
You got to be a nuance king. It's the world of the nuance king. Everything is interrelated, and you have to,
Everything is, and you have to have answers for questions that you might not think are important, and that the universe has increased not the universe, but our world has increased in complexity, and the more demands are placed on each individual than ever before. So we need to grapple with that. Anyway, I like talking about this stuff. I hope even when you get into stuff like spin networks and spinfoam, even the book has to kind of gloss over that, because it's very highly theoretical, and to explain this stuff doesn't make sense. Because I hear spin foam, I'm thinking, okay, like foam, like a bath, no, but it's like a balance sheet of its movements. And so this idea of space is something that can be occupied. We're just occupying a balance sheet of interaction. See what I'm saying? Like what then that I'm like, okay, that actually makes it more practical. That brings science down to a level of stuff. It's not just materialism. It's not just that. It's like you can understand the forces, and now that we understand the boundaries, I think it's easier for us to exist within the system once we know what the boundaries are. Anyway.
Do not let the rapists win. Listen and love Blood Satellite.